Namaste one and all. So today we will be considering the concept continuous charge distribution. So till now you studied regarding the charges by assuming that the charges are point charges, and you have calculated force between two point charges. You have found electric field, and the electric field lines are coming out of the single charge. So whatever you have calculated, it was discrete in nature. That is, you have considered individual elements as a charge, and you have calculated everything. But we have done this so that mathematically we can calculate this easily. So but in real world this is not what it looks like. In real world the charges will not be discrete in nature, but it will be continuous in nature. So, whenever we deal with discrete, handling mathematics is very easy, but when it becomes continuous in nature, so we need to go for calculus. So, it would be difficult to deal with calculus. So, dealt with this using a discrete charge. Now you are aware of everything. Now let us consider the real world applications where we will be dealing with continuous charge distribution. So it can be a surface charge. So there will be a surface on which the charge will be distributed uniformly. So if we consider this square surface, the total amount of charge present on this will be given as plus q. Okay, similarly if we consider line charge, the total charge on this entire line is given by plus q. Similarly if we consider the volume, okay, if we consider this cube, the total charge which is distributed uniformly over this is given by plus q. Then how do you calculate uh, the charge force and all the other characteristics for this? So what we do is, let's consider first continuous charge distribution. So the surface is area is S, and the total charge when we add up, that gives you the value of plus q. So what we do is we first take a small surface out of this entire surface, and we call that as delta S. So this small surface is called as delta S. So and the charge present on this small surface is delta Q, and we call this as surface charge density uh, sigma, which is given by delta Q divided by delta S. So the charge density over this small surface is called as surface charge density, that is delta Q by delta S. So once we are able to calculate this much amount of area charge density, then we can integrate this element in order to form the entire surface. So that is the approach we'll be using in case of continuous. We'll be taking a small element and we'll be calculating that charge present over the small element. Since it is uniformly distributed, we can integrate that to find out the charge present on the entire surface. So this is for surface, and it is given by sigma. Similarly, if we consider line charge distribution, so this is the line of length L, and the total charge is given by plus q, which is uniformly distributed over the line. So if we consider, if we need to calculate, or if we need to perform any operations, so we will be considering only part of the line, so that is given by delta L. So the amount of charge present on this small length delta L is given by delta Q. So this is the line charge density. Line charge density is given by lambda, which is equal to delta Q by delta L. So if you are able to calculate the charge density present over this small area, then we can calculate the entire charge distribution by integrating this element. So that is how the approach is. So this is for line charge distribution. It is given by lambda, which is equal to delta Q by delta L. So the same approach we'll be using for the volume charge distribution. In case of volume charge distribution, instead of considering the entire volume, we'll be considering the small volume delta V, and the charge present on this delta V, the small volume, will be delta Q. So we call the volume charge distribution as rho, which is equal to delta Q divided by delta V. So this is how we'll be dealing with the real world, where the actual charge distribution is continuous in nature but not in discrete. So at the starting we have used discrete charges just to make the mathematical approach easier. But in real world we need to go for calculus. In calculus we'll be taking only a part of that and we'll be calculating everything, and then we can apply that to the entire surface by integrating that small element. So that is the approach. I hope you have understood this concept of continuous charge distribution. Okay, thank you for watching. Thank you for watching the video. I hope you have understood the concept. So to know whether you have understood the concepts better, you need to answer the quiz. The link for the quiz is given in the description below. After answering the quiz, you will be getting the result. So retake the quiz until you find that you have answered all the answers correctly and got the complete out of out results.